Good evening, guys. I'm just going to get started now. I know a lot of people are still joining, but we'll start getting underway because it's turned 6 o'clock here in London. So, good evening. Welcome to another one of our AI for Good webinar series this evening. Tonight, we're lucky enough to have 3 presentations presenting on the fight against AI bias. Through the course of the evening, you'll hear from our experts on how they see the fight against AI bias through the understanding of holistic data, best practices, explainability, and more. Our 3 speakers for this evening are Avriel Epps-Darling, Ph.D. candidate at Harvard University, Wael Abd-al-Majid, Research Associate Professor at USC Viterbi, and Nazneen Fatima Rajani, Senior Research Scientist at Salesforce. So a little bit on the format of the evening, there'll be 3 15-minute talks, followed by a group Q&A session at the end with all the speakers. If you run into any technical difficulties at all, please email my colleague John on john@rework.co or visit our website and use the live chat option there, and they should be able to help you. Throughout the webinar, you'll see that we have a question or Q&A section at the bottom in your toolbar. So if you have any questions for our speakers, make sure you get those in throughout the webinar and we can answer them all together at the end. Without further ado, I want to introduce to our first speaker, Avriel. Avriel Epps-Darling is a PhD candidate, Ford Fellow and Presidential Scholar at Harvard University. As a scholar, she's garnered numerous awards and honors, including an invitation from the US Department of Education to present on her work for Congress at Washington D.C. and recognition as part of the top 10% undergraduate social scientists in the world. This evening, Avriel will be presenting on YouTube recommendations in the Black Lives Matter movement. Over to you, Avriel, if you'd like to share your screen.
Great, thank you so much for the introduction. Give me one moment. Cool. Does everything look good, Luke?
Everything looks brilliant. Yep, over to you.
Okay, cool. So, hey everybody, I am going to talk about a research project that I'm currently in the middle of. So there are a lot of unanswered questions here, but I hope one of my goals today is to really talk through some of the challenges of doing research in a large scale data set with a really diverse set of data, as well as just kind of talk about some of the interesting initial findings. I'm also going to do just like a really simple introduction to how my research kind of at the intersection of social science and computational science may differ slightly from what we traditionally think of as AI bias or fairness, accountability, and transparency in AI work generally. So let's get started. All right, so when we think about anti-Black technological racism in the social sciences, we're primarily concerned with content. And this is stuff like racist memes, racist TikTok videos, things that are triggering to the individual who may come across this. And as we're concerned, as folks on this call are primarily concerned, we also think about these algorithmic biases. And in general, when we think about algorithmic biases, I think some key things that come to mind are things like sentencing algorithms or Google's image search algorithm. And these are really, really important because obviously they have real world consequences for the individuals who come into contact with these systems in various ways. But what we tend to not really think about is this psychological slow burn for the quote unquote average person who is in contact with or encounters biases in everyday technology. And what that does to our psychology as time goes on. With that said, one really famous example of this is YouTube's recommendation pipelines and the work that's been done by some of my colleagues around alt-right radicalization. YouTube has since altered their algorithms to minimize this effect on viewers. And so we're gonna kind of flip the script on that with this research project and try to understand what's going on the other end of the spectrum in terms of content, specifically after the death of George Floyd with content around the Black Lives Matter movement. So as I'm sure we're all well aware, in June, or after the riots after the protests around the world really ignited, towards the end of May and the beginning of June, a lot of social media giants came out in support of the Black Lives Matter movement, and specifically its mission. But what we wanted to understand is, well, one, what is the relationship between Black Lives Matter related content and the users who are creating and viewing this content, and how does that reflect what's already going on these social media platforms, specifically YouTube, and not necessarily to prove that YouTube is not doing its part, but to provide a kind of foundation for understanding what needs to change. If a company or if a platform like YouTube is in support of Black Lives Matter and its mission, how is it treating Black Lives Matter related content, and where does it need to go from here? Where does it need to improve in order to really support the mission, really support the movement? And so that is our research question, or one of the larger overarching research questions for this project. It's a really simple one. Does YouTube's content recommender support the Black Lives Matter mission? So we ran into some really key issues right at the beginning of this project around two things: data collection as well as data annotation and labeling. And so the way we kind of decided to go about collecting the data happened in two rounds. The first was, we're concerned with two forms of recommendation. The first form is search recommendation. So what videos are you exposed to when you go to YouTube to look up information about Black Lives Matter, as well as the recommendations that lead you down the viewing pipeline. And so that is, once you're on a video, what do the recommendations that result from that video, where do they lead you to? What kind of content would you be watching after, say, 30 minutes of a viewing session on YouTube if you started off from a particular video? And so in order to do that, we had to choose a set of seeds, search seeds. And this was also really difficult, because how do you decide what are the 50 search terms that capture the essence of the movement? Particularly because Black Lives Matter is a movement that has been going on far before the death of George Floyd, the tragic death of George Floyd. And so in order to do this, we reached out to the core group of Black Lives Matter organizers that are coming out of LA. And we just asked them, what are some of the ways in which you're tagging your own work, so that because social media organizing is a huge component of what they do in addition to the on-the-ground work. So we collaborated with those organizers to build a list of seeds. This isn't the entire list of search seeds that we used, but and particularly what was difficult was finding the anti-movement seeds. So things like hashtag Blue Lives Matter, and kind of all of the stuff that's happening in the world that I am and my co-author are not really a part of. So already we're coming up against some individual biases that are informing the research, particularly because of filter bubbles that exist on the internet, where we're just not even exposed to kind of the anti-BLM content. And so overcoming that, I think what was really important for us was to work with the community and work with the organizers who are doing this work. And you'll find that, and we found, later phases of the research, that coming back to working with the community was really important and pivotal for the actual completion of the annotation of the videos. So So let's talk about that, labeling the data. So to label a few thousand seeds or a few thousand videos by hand is not necessarily that difficult. It would take some time, but it is feasible. But as our data set of the pipelines grew, we've got about 3 million videos now. And so how do you do that without using computational methods? It's really difficult. The problem is that knowing kind of the biases that exist in the models that we could be using to label this data, it becomes really difficult to do a project on exposing algorithmic bias without infusing some of the bad biases into your own data. And so, so one of the ways that we tried to overcome this was, again, to go back to the community. So to lean on kind of a crowdsourcing model of labeling the data, particularly targeting folks that are concerned with the movement because, and communities of color, particularly Black communities, because there are two things here that we're trying to overcome. One is if we were to use facial recognition models to code the race of the folks who are creating the content, there's obviously a whole host of issues in doing that. And also, coding somebody's race is a really nuanced thing. I might be labeled as a Black person by another Black person, but as somebody who doesn't come into contact with Black people regularly, my race might be read as a little bit more ambiguous. My son is also a really light-skinned person with blonde curly hair. And so the average person would probably not label him as Black, but somebody who comes into contact with mixed race or light-skinned Black people regularly would find kind of the nuanced differences in his phenotypes and be able to label that. So we really wanted to lean on human coders to do this. And similarly, we knew that there was a lot of linguistic diversity in the transcripts of the videos that could be used to label things such as, is this video pro the movement or against the movement? What is kind of the bias that exists there in its explanation of what BLM is? So we need to account for things like, users who are kind of like lay YouTube creators, not necessarily, news channels, but folks who just do commentary on various things. A lot of the videos in our data set are like beauty videos and Black women doing beauty videos, but talking about Black Lives Matter at the same time, which is kind of like an interesting subset of or an interesting niche in the YouTube community. And so, like, how do we account for folks who have dialectical differences? They may be using African-American vernacular. They may have, Black folks in the South have different slang and ways of talking about things than Black folks on the West Coast and Black folks in the UK. And so, again, it's really important to get kind of a diverse community of people of color to help us parse through some of these differences rather than really relying on computational tools to categorize these videos for us. So that's how we really chose to approach this. We had a panel of folks, or we're still working through this process, so undoubtedly we're gonna come up against some other issues, but we have a panel of folks who multiple people are kind of coding each video, and these are just random folks across the internet that were asking to help us do this. Okay, and so some of the things that we're interested in coding right now are like, what is the type of channel? And specifically, what are these like, different sub-communities? So not just beauty channels, but beauty channels who also occasionally engage in political commentary. Are they for or against the movement? Are they somewhere in between? What is the political bias of the channel? Luckily, there are some really great resources that already exist, and data sets that already exist that help us answer that question. What's the race of the main speaker of the video, and what is the race of the channel or company owner in the case of like larger channels like ABC News? And so we have some really interesting initial observations. One is that because YouTube recently changed their algorithm for search recommendations after, after a lot of critique around the far right radicalization pipelines, the vast majority of search recommendations lead us to news outlets. And so, and as we know, there's a huge diversity issue in the world of both local and national news, where the vast majority of folks who are commentating on this or reporting on this are not Black people. And so right then and there, you have this example of how Black voices are not being centered in the conversation. But another interesting conversation is when you're looking at the most viewed. So if you do a search and instead of you looking at most relevant recommendations, you're getting the most viewed videos that are coming up in the search results. You see a lot of alt-right commentary, or at least conservative or right of center or far right commentary. And this is because even though, well, one of the theories we have on this after talking with the folks that do this kind of far right radicalization work is that even though YouTube no longer recommends, so they say, this kind of content, these communities exist elsewhere on the internet and they're still uploading content to YouTube and then disseminating it on Reddits or 4chan or 8chan and all these other platforms and finding audiences for it. And so, one of the questions we have as we start to dive into what the recommendations for like the up next feature after you're already watching a video, what you end up watching next is, does the view count and the popularity of these conservative videos end up biasing the recommendations of the videos kind of towards the right versus towards the left? Understanding there being that things that are more right-leaning are more critical of the movement, things that are left-leaning are more pro the movement. And particularly, if the argument around YouTube recommendations is that it really just leads you towards the extremes, not necessarily the extreme toward the right, but it could also lead you towards the extreme of the left, does that lead you into commentary that really supports some of the more radical calls of the movement, like abolishing the prison industrial complex entirely? When we think of this, it's the work of folks like Angela Davis. And I think that's where the major contribution of this work is probably going to land if we end up having a finding of that sort, because there's very little work that's looking at what's happening in the extreme left side of the internet, and particularly when it comes to issues of racial justice, because the little bit of work that's happening in that area is really showing that the folks on the extreme left in these communities tend to be overwhelmingly white and male still. So those are kind of the open-ended questions that we have as we continue down this research. And I'm looking forward to your guys' questions and observations as well, because we're very much still trying to figure this out. And I'm sure that the folks on this call will have a lot of interesting insights to add. And I'm gonna stop there. Thank you very much.
Brilliant. Thanks, Avriel. Really interesting presentation. As I said before, if you have questions on Avriel's presentation, make sure you pop them in the Q&A section below, because we'll get them around to those at the end of all three talks. But yeah, thank you very much for the talk. Very interesting. Up next, we have Avriel Epps-Darling, a research associate professor at USC Viterbi. So Dr. Epps-Darling is the research associate professor at the Department of Electrical and Computer Engineering and a research team leader and supervising computer scientist with information sciences at USC Viterbi School of Engineering. His research interests include representation learning, debiasing, and fair representations in multimedia forensics. This evening, we'll be presenting on multimedia forensics in the age of GANs. The war has apparently just begun. Over to you, Will, if you'd like to share your screen.
Luke, thank you so much for the introduction. Do you see my screen?
I do indeed. Yep, brilliant.
Thank you. So thanks again for the introduction. My name is Avriel Epps-Darling. I'm a research associate professor at USC Viterbi School of Engineering. And I will talk briefly about some recent work we did on multimedia forensics, and then use it as a segue into bias and ethical AI. So some of you might already have seen this video, maybe not.
Complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time.
So actually, it is a dangerous time. And for those of you who haven't seen this video or similar types of videos before, this is what's so-called deep fakes, where people actually use deep neural networks to generate fake videos of a target person who's the victim, and basically making this person say, or it looks like this person has said or did something he never said or done before. And deep fakes are extremely dangerous because they have significant implications of, in terms of misinformation and national security.
Once upon a time, I called
for the interest of time, I will not play this video, but this is an example of a video that came out in the UK a while ago, and it was meant to be an educational video on the dangers of deepfakes. There is huge amounts of deepfake porn videos out there, and basically many people, including celebrities, have given up the fight to basically protect their privacies and identities. There is huge dangers in terms of child exploitation, stock market manipulation. If you think, for example, somebody can come up with a deep fake video for Jeff Bezos saying that Amazon is losing money, and Amazon stock could literally collapse just in a matter of few minutes until people will figure out that this is a fake video, until the stock rebounds again. People can actually cause stock market manipulation and make huge amounts of money from deep fakes. It can be used to tamper courtroom evidence and insurance frauds. As of last September 2019, Deep Trace, a company in Italy, basically issued a report to the state of deepfakes, and back, which was almost a year ago, there was about 15,000 deepfake videos online. The numbers have grown exponentially since last year, and it is actually causing a big harm to national security, and everybody is worried here in the United States now in terms of the upcoming elections, because everybody's anticipating adversaries will create deepfake videos to tamper with our democracy. So I will not go through all of these statistics. I'm just trying to show the importance of this problem and why we actually have to continue developing methods to combat multimedia manipulation. There are a number of key challenges in terms of developing technology that can actually detect these kind of multimedia manipulations, deep fakes, or GAN-generated images, including the same technology we use, the same AI technology we use to combat deep fakes is exactly what deepfake generators actually use. It's pretty good, it's extremely sophisticated, and the generation technology is fascinating. When we actually train detectors, we have difficulty making these detectors generalize across data sets. We train on a certain data set, and then somebody comes up with another data set, and the detectors have hard time generalizing. State-of-the-art detectors, deepfake detectors, do not scale well. And scalability is basically a sort of a two-faceted problem. These detectors do not scale in terms of the number of subjects. They are usually trained to detect manipulations for a specific number of subjects, like celebrities and politicians. And also they don't work well at an internet scale in terms of both computational complexity that cannot handle extremely large numbers of deep fakes on social networks, and also in terms of false alarm rate. Most of the existing methodologies or technology for detecting deepfakes do not handle forgery laundering methods really well. And for example, people who generate deep fake videos usually run it through extremely high compression rates, so that it becomes harder for detectors to actually find out traces of forgeries. And of course, we can train our detectors to detect a certain number of deepfake generators, and then somebody tomorrow will come up with a new neural network or a GAN that basically can generate a new type of deepfakes that's more sophisticated, and we still cannot or not able to basically detect unknown attacks, what I like to call unknown attacks or unknown forgeries. So coincidentally, today we're actually presenting a demo of our state-of-the-art deepfake detection neural network in the alongside with the European Conference on Computer Vision. The demo of our system is today, and we also have a paper in the main conference of the main ECCV conference describing our method. I'm not going through the details of this. This is a state-of-the-art network that includes basically handling or detecting high-level features, low-level features, and novel mathematical formulation for making our network basically generalized to unseen attacks. A couple of weeks ago, and for those who are interested in numbers and statistics, please refer to the paper in the main conference. A couple of weeks ago, a friend of mine sent me a new video that was created by MIT, and I'm not going to play the main video, but I will show you the detection results of our deepfake detector. This is basically a video of Nixon saying that the Apollo 11 mission has failed and the astronauts basically are trapped on the moon, which obviously never happened. MIT researchers created this video to make the public aware of the dangers of deepfakes. And without knowing anything about the technology that was used to create this video, we ran it through our system, and this is the result.
Good evening, my fellow Americans. Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace.
So obviously, as you have seen, this never happened. Nixon never said that the Apollo 11 was actually a success. But if you have seen here in the video, we can, as this slide is showing, we can actually tell in real time that this face is actually manipulated or fake. And this video has never been, is actually not real. And as I mentioned, we ran our system out of the box on this video that was created really carefully by MIT, and we were able to successfully detect that this is a deepfake. The reason I'm actually discussing deepfakes is not necessarily to discuss the technology that we have developed. We have been developing, this is the second generation of the technology that we have been developing for years now in my lab. But actually, I want to use it as a segue into AI ethics or ethical AI, which is part of this AI for Good series. So what do we actually do as AI researchers over the last many years? This tweet has actually stopped me and made me think for a really long time when it came back about 6 months ago from Hinton, who is one of the godfathers of AI. And the tweet basically says, if you have an AI surgeon that cannot explain how it works, but has a 90% cure rate, will you actually use it or choose it over a human surgeon with AI with 80% cure rate, but can actually explain its results? And because of who he is, who tweeted this, I stopped for a long time and I was thinking about it and whether this is actually true or not. And then a few hours later, another tweet came from another godfather of AI, Ian LeCun, basically saying, of course not. And it made me think whether this is actually true or not. And I started thinking about issues that are related to this webinar. So what's the false positive rate of this AI surgeon? how many people is it going to kill for each 100 people that it will actually operate on. Who's going to certify it? Is it going to be just a couple of people who are publishing the paper and basically they will say it's a success, and now we have to use the surgeon to operate on people? Who's liable for these false positives? What if the surgeon actually kills someone? Who's going to be liable? Is it the researchers? Is it the hospital? Is it the government? Is it biased? Is it biased against Black people, like what we have seen lately in terms of face recognition systems? Is there any algorithmic bias built into the AI surgeon? How is this AI surgeon is dealing with confounding and nuisance factors, some of which are known, like gender, ethnicity, and age, and some of which are even unknown, because in people who are developing AI and representation learning methods are very well aware that most of the time our systems overfit to the underlying training data without, with usually a large number of unknown confounding factors, and so on and so forth. How about poisoning attacks? How about privacy and model inversion? How about adversarial attacks against these against this AI surgeon? And all of these questions are not answered in any of these 2 tweets by 2 of the godfathers or the founding fathers of modern AI. It's extremely dangerous message. So what are we actually doing? We're actually developing extremely dangerous technology that can sway elections, it can shame women, it can exploit children, it's unfair and biased against minorities, and it can crash stock markets. And we do that completely recklessly without thinking about how we should actually deploy the technology. We tweet some things like this, and we're literally misleading the public, because none of these 2 tweets are even close to reality of AI systems now. It's not even close to developing an AI surgeon. We're literally misleading the public. And another example of our recklessness as AI researchers is we rush into applications, including, for example, face recognition, which has gained extremely negative sentiment lately. And this video shows another major issue or major limitation of existing AI technology, where a simple patch on the right-hand person's stomach basically makes the system unable to know that this is a person. So think of this as a human detection system deployed on a self-driving vehicle. Once this is deployed, right, we can literally kill a person because we are reckless and we are not honest in terms of what the limitations of the AI technology we have been developing. And we just want to rush into applications, and we're misleading the public. Let alone that we have a major reproducibility crisis. These numbers are from 2016 from Nature, and computer science people are well aware, and electrical engineering, computer engineering people are well aware that our work is simply not reproducible, or at least not easily reproducible. And by reproducibility, I don't mean downloading a pre-trained model on ImageNet from GitHub and reusing it right away. This is not reproducibility. Reproducibility means I need to take an untrained model, train it exactly with the same recipe that was published in a given paper, and end up with exactly the same results that are in the paper. If I cannot do this from scratch, this is not reproducibility, and we are nowhere close to an AI surgeon. So if we cannot reproduce our own results in the computer science community, how do we expect that the FDA will actually certify that AI surgeon? And that's exactly what we have seen lately. The Detroit police used immature face recognition technology to wrongfully accuse a Black man because the AI algorithm basically said this is a best match. which wasn't, because the underlying technology of that AI recognition or face recognition AI system was not audited properly. Nobody has any idea what was the data set that was used to train this AI system, whether this data set is actually balanced or not. Does it include equal amounts of training data for white and black people, for men and women, for old and young? We just had no idea. And people basically rushed into, or police departments and law enforcement agencies rushed into using this technology, and they started basically showing bias against black people. And at the end, this is what happens. What happens there is that different states are now banning the technology. Just a couple of months ago, when these incidents started basically gaining popularity or showing up in news stories, Microsoft, Amazon, and IBM all decided to stop developing this technology. And despite many people, many voices in the AI community for years saying, we are not there yet, we are just not there, and it's not good for the public to basically push this technology, we will basically erode the public trust in our work. And that has extremely bad long-term side effects. And at the end of all of this, this is basically what we do. We act as if we did nothing. I did nothing, we are great people, we develop technology, we are smart people, and it's not our mistake. While actually it is, because we weren't honest enough to basically say, yeah, we are working on cutting edge technology, but it still needs years to be mature enough for deployment. And this actually reminds me of something that happened in the stem cell research community many years ago, more than 2 decades ago. When two people basically were able to derive the first human embryonic stem cell. And that actually stirred or started a debate in the community on the ethics of doing stem cell research, which is actually something that we are lacking in the AI community now. The AI community now needs an honest and open community debate on the advantages and limitations of existing AI technology. We need to exercise some sort of self-censorship. What could, basically we need to ask our questions, what could adversaries do with our technology? If I'm creating a new GAN or a new deepfake generation network and I'm happy with the results, I need to start thinking, what if an adversary uses the same technology, which will basically be available in my paper or in my GitHub repo, to generate videos that can mess up with my own democracy? Should I share my code or not? What should we do as researchers? Should we invest our energy and cycles into developing technology that can basically be used not for good? Or should we actually focus on maybe applying AI to AI for good applications, like medical applications? And are we ethically and morally responsible for what we develop? Or are we just free to develop anything without any moral or ethical constraints? And then it's up to downstream companies who will basically use this technology to develop something maybe we didn't intend. And I don't claim to have answers to these questions, but what I'm saying is that the AI community is in serious need for an open and honest debate. Two concluding thoughts. After working for like 5 years now in multimedia forensics and image and video manipulation, I really don't think that seeing is believing anymore. Seeing is no longer believing. And when we actually see a video or an image on Facebook or Twitter, we need to start thinking many times before we reshare it. We need to teach our kids and colleagues to stop and think about the consequences of sharing something that may be not true, like the Obama video or the Nixon video. And again, fighting AI bias starts from within the community. Before we even starting to think about building unbiased data sets or developing unbiased and fair algorithms, we need to start thinking as a community, what should we do and shouldn't do. And as I always like to say, ethical AI is not something we actually say, it's something we do day in and day out. Thank you.
Brilliant, thanks for that, Wael. Some really interesting points again from yourself. As I said before, if anyone has any questions on Wael's presentation or any of the points he's made, make sure you get them in so we can ask them to him later. But without further ado, I want to go into our final presentation of the evening from Nazneen Fatima-Rajani, Senior Research Scientist at Salesforce. Nazneen is working on common sense reasoning, interpretability, and robustness. She received her Ph.D. in computer science from UT Austin in 2018 and has had her work on debiasing word embeddings published in various top-tier conferences. This evening, Nazneen will be presenting on tailoring word embeddings for gender bias mitigation. Over to you, Nazneen, if you want to share your screen.
Hi, can you all see my screen and can you hear me?
Yeah, perfect. I can see the screen and I can hear you as well.
Awesome. Okay, great. Yeah, thank you very much for the introduction. I'm very excited to present our work on tailoring word embeddings for gender bias mitigation. So this is work done with our intern Tian Lu and my amazing colleagues here at Salesforce. This work is published at ACL earlier this year, a top-tier conference in NLP. So word embeddings are known to exhibit gender bias. This is because the data that our models are trained on is historic and has stereotypical biases. Word embeddings are basically just vector representations of words in natural language. So in this figure, the x-axis represents a projection onto the difference between the embeddings of words he and she, and the y-axis captures the gender neutrality, with gender neutral words above the red line and gender specific words below the red line. Ideally, the projections of gender neutral words should be in the middle region, equally close to she and he. A good example in this figure is the word parts. However, we can see that there are some stereotypical alignments. For example, genius is close to he and homemaker is closer to she. By definition, genius and homemaker are both gender neutral words and should not be biased towards any gender. As you can imagine that deploying such a system can have harmful consequences. So to debias word embeddings, previous work has first identified a gender subspace by computing the principal component analysis of some gender specific word pairs. And then they project away the gender subspace from biased word embeddings. After debiasing, words in a subspace orthogonal to gender, thereby making them gender neutral. So as you can see, like the projection on the right is like has words that are more closely clustered, and the assumption is that we have made them gender neutral. The crucial step here is to determine that gender subspace so that you can get rid of that gender dimension. So in our work, we observed that the word frequency can distort the gender subspace and limit the effectiveness of this previous method. Ideally, we would expect that the word vectors are distributed based on their semantic meanings. That is, for example, a king is close to a queen and a doctor is close to a nurse. However, in reality, the word frequency can significantly affect the geometry of these word embeddings. Previous literature observed that word embeddings capture frequency information that make them cluster in different subregions of the embedding space. So more importantly, this can have a negative impact on identifying the gender subspace because now the word vector geometry is twisted because of the effect of frequency. So in other words, because word embeddings capture frequency features, the gender subspace is actually distorted and far away from the real gender subspace. This prevents previous methods from completely removing the gender component. So what our method does is, our method attempts to improve on the previous method by mitigating the influence of word frequency on gender subspace. So our core idea is that before we eliminate the gender dimension, we first transform word embeddings into an intermediate subspace to get rid of the effect of word frequency. And the goal is to revise the embeddings to remove the frequency features. And with those revised embeddings, we can identify a more accurate gender subspace and achieve better debias performance. Next, we focus on how to transform the embeddings to remove the word frequency features. So here are the 2 steps to do that. The first one is we use principal component analysis on word embeddings and treat the top principal component as potential dimension that represents frequency. And this has been motivated again by a previous work. And then we project away from the frequency direction and get the revised embeddings. We then compute the gender subspace and project it in the orthogonal direction to obtain the debiased embeddings. Next, we cluster the male and female words to see if any gender bias exists. If there are distinct clusters, like you can see over here, the purple and green, we know that if the debiasing was not successful, and then we go back and repeat this process. So this clustering experiment serves as a proxy to provide feedback on whether the current candidate frequency is the one that we want to find. And if the debiasing was not successful, we keep trying another candidate frequency direction until we get what we need. And so once we obtain a more homogeneous cluster, like shown in this figure, then we know that there are no 2 clear distinct clusters that we had previously, then we stop, and the assumption is that we have been able to get rid of the gender dimension. So we evaluated our approach, which is basically a heuristic-based approach, on window bias data set that tests for gender bias in co-reference systems. So each example has a pro-stereotype subset and an anti-stereotype subset. An example from the data set contains a pro-stereotype sentence. The physician hired the secretary because he was overwhelmed with the clients. And an anti-stereotype sentence. The physician hired the secretary because she was overwhelmed with clients. And so this is where we tested, and we obtained a significant amount of improvement. And in particular, we obtained 12% improvement over the previous method that I just described. So here are the takeaways from our paper. The word frequency is encoded into word embeddings and changes the geometry of the embedding space. So we should not ignore that. And more importantly, removing the word frequency feature from embeddings helps to improve the existing debiasing algorithms. And we found that our method beat the best performing debiasing system by 12% points on this very well-known window bias data set. And it was only at the cost of 0.1% drop in performance accuracy. That's all I have. Thank you. And here is a link to the code so that you can reproduce our results, and also a blog talking about our paper in more detail.
Brilliant. Thanks for that, Nazneen. Another really interesting presentation. So we've got a couple of minutes now to go through some questions that we've had put in, as well as some of the pre-submitted questions. The first one I wanted to put to you, someone had asked prior to the webinar, do you see, especially, I know you talked a lot about deepfakes, but do you see that there may be an increase of these in the lead up to the election and other sort of political events that are going to be happening very soon?
I do. I think we will be seeing an increase in the deepfakes, and the increase does not necessarily mean the number of deepfakes. It can be just a single deepfake video of, let's say, Joe Biden attacking the Black community 6 hours before elections, and the problem is not the single deepfake. The problem is that you put it on Facebook or Twitter, and some troll factory will basically make it go viral, it can literally sway, one single deepfake can literally sway elections. By the time polls close and people realize that this was actually a deepfake video, the elections will be over. So the danger is not necessarily the number of deepfakes. The danger is deepfakes married to social networks and, as I mentioned, ignorance of people who just recklessly share deepfakes. In the meantime, to be completely transparent about this, I don't think existing social network platforms, including Facebook and Twitter and YouTube, are keen on fighting misinformation. I haven't seen any serious efforts to actually combat misinformation. They want to save their public faces. They announce a lot of initiatives without doing something that actually works. And I am not suggesting, for example, that the technology that I showed, my technology, the second generation, will detect every single deepfake out there. It's almost impossible. From a scientific perspective, we will have false alarms and we will have false negatives. But they are not even interested in deploying something that can detect the majority of deepfakes out there.
Okay, and I want to come to you, Avriel, as well. We've kind of touched on this in other webinars and things as well, and at some of our previous summits, we've had people discussing AI ethics. Did you believe it's something that needs to have almost a universal code for ethical sort of standards and standardization? Because otherwise we're kind of working to different platforms as ideas of what should and shouldn't be sort of ethical.
Yeah, I think there's maybe two ways to think about answering that question. You know, in one way, it does make sense to have a standard of ethics that scientists and community leaders really agree upon, because these are transnational corporations. They all should be held accountable to a similar standard, and it's difficult for individual countries per se, to say this is our standard, these are our legal standards for this, like GDPR versus what the US does. And so that creates a lot of tensions within corporations, and it also kind of creates this uneven accountability across different communities around the world. From my perspective, as somebody who's interested in issues around racism, anti-Blackness works similarly beyond borders, and anti-Blackness is a pervasive issue around the world. And so when you're thinking about issues that particularly speak to anti-Blackness, there are kind of ethical standards that we can think of that are applicable to different parts of the world. But another issue to think about is like different marginalized communities have different needs, and those communities need to be listened to in local contexts. And so it's really difficult to account for all of those things when you're trying to create ethical standards that are easy for organizations to adhere to. So it's a really difficult problem to solve, obviously on a technical level, on a scientific level, as well as on a social level, because there's so many competing forces. And even on a social level, there's just so many competing approaches to solving it.
Sure. Another one, Nazneen, I know you've answered it sort of in the Q&A section there, but could you kind of roughly touch on the question that you'd answered? An attendee had asked if COVID had seen a change in, COVID and the change in workplaces and working from home is kind of had an impact on gender bias at all?
Right. So yes, there's no doubt the answer is yes. And we already have data that more women tend to, give up their jobs or let go of their jobs when there's a situation where one family member needs to look after either the family or kids, and we have data that shows that it is predominantly like the women that do that. And so obviously there's no doubt that there is bias in that as well. And obviously we can feel that like the effects would be more long-term as opposed to like, just during the COVID phase, because now that, there's like this kind of like a gap again in employment where we are trying to like, kind of close the gap between men and women and, try to pay them equally and try to give them opportunities equally. But then if there is like, data for this, and like the effects would be more long-term and even the post-COVID era.
Sure, brilliant. Another had asked a question, which I think is actually quite applicable to kind of all talks. So I'll ask you all to kind of briefly touch on this as well. But someone had asked, how can public sort of anxiety or apprehension towards AI adoption and development of AI be somewhat reduced? Obviously, we have sort of community conversations and things like that. But personally, how do you personally have any opinions on how we can sort of reduce public anxiety or apprehension towards AI adoption? Whale, if you have any points to go first on that one.
I can't claim to have an answer to this.
Sure.
What I can say is that, as I mentioned in my talk, this requires a debate within the AI community first, because many people have been saying for years, AI technology is great, it's promising, and it is showing superhuman performance on many things, but most of the cases, it's nowhere near ready for being used for the public yet, including, for example, the famous example, face recognition. And I have been doing face recognition for 6 years, and I don't have any trust on face recognition systems. It's just completely broken, because, and that's not necessarily a bad thing, because this is basically the whole idea of doing research. When we started doing face recognition 6 years ago using AI, we had a great data set from Oxford that was pretty much the biggest data set public data set back then, a few million images, 2 or 3 million images. And we were very happy with our technology. But as we started seeing the holes and limitations of the technology, I can come back and say to you now, no, we are definitely not ready. So I don't have an answer to what should be done, but at least we should start a debate within the community without hiding the limitations of the technology and basically misleading the public.
Sure. Nadine, did you have a point on that?
Yeah, if I can add my 2 cents.
Sure.
So I feel like we as researchers and people interested in AI have the onus to deal with that, in the sense that when we put a model out there or put an AI system out there, we should not only say like how well it performs on the average case, but also how well it performs on the tail data where we don't have enough data coming from, for example, minority racial data or the female gender data. And so the other thing is like, people have come up with this idea of model cards where you put down like, what are the limitations of your approach? So the onus is on us to identify what those limitations and biases are of our system and sort of like put it out there so that people trying to use that or deploy that are aware of that. And they also know how much robust is it. So because right now we know that AI, especially in NLP, is like crushing all these benchmarks, but then we know that that is only when the data is coming from the predominantly like IID distribution, right? But when it is coming from the long tail, the performance is like way worse than even random. So I think that is where we need to be aware of, and the onus is definitely on us.
Brilliant. Okay. Obviously, we've only got a couple of minutes left anyway. So one thing I wanted to kind of ask you all was what you would like to achieve in your work, what you would like to sort of see develop in your work kind of by the end of this year. Do you have any longer term visions, or is there anything you're excited to be working on? Well, if you want to go first.
So yeah, I mean, the general view for my research in the next few years, including my group, is that basically 2 things. One is raising awareness in terms of the limitations of existing AI technology, in one of my slides, I listed like 8 different limitations, and these are very well aware. Everybody in the community is very well aware of these limitations. So it's basically raising awareness. And on the other hand, trying to find ways to apply, to do AI for good. What can we actually do in terms of using AI to help people?
Okay, brilliant. Avriel, any plans for the rest of the year? Anything you're excited to work on?
Yeah, I mean, I'm currently working on a course for Harvard X, which will be kind of an open platform course for anyone to take who's interested in data science around issues of ethics and privacy and how to think critically around these issues. And I think one of the things that I'm particularly interested in and excited about as it relates to that course, but also my work more broadly, is getting back to some of these more foundational issues and questions around what are our goals in developing these technologies, and are those really valid and helpful goals? You know, for the purpose of facial recognition, for instance, since that was brought up earlier, is it necessary to develop that technology? And like, is it the possibility for harm generally may completely outweigh the potential benefits, and kind of intellectually, obviously, it's a really interesting problem to work on, and scientifically, it's an interesting problem to work on. But in a kind of capitalist, white supremacist, sexist, heteronormative society, does working on these problems help to reduce the harm that happens to marginalized communities at the hands of corporations and governments? And this may be a really unpopular question to ask, and you know, my colleagues on this call might completely disagree with me, but I think we need to begin asking some of these more foundational issues of why are we doing this work, and you know, if we're not doing it, who will be doing it? And so that might be a perfectly valid reason to do it. Like, we are obviously care about doing good with AI, and there are many people who are capable of doing this work that are not so much interested in that. But yeah, I really think that I want to continue thinking about these things and advancing the questions in spaces like this.
Brilliant. And yourself, Nazneen?
Yes, so I plan to work on interpretability and robustness, and sort of motivated by what I was talking about earlier, is that you know, and specifically for NLP models, we know that they perform well on average case, but then their performance is not that great when your data is coming from these minority distributions, right? And so my work is basically focused on identifying the weaknesses of these models and sort of exposing, like, what are these models relying on for making their predictions? Are they actually able to do reasoning, or are they just relying on some superficial patterns?
Okay, brilliant. Obviously, we've